Good morning, everyone. Mr. Penchurski back. Today we're going to do our second part of area of a triangle. I did a initial video originally yesterday showing just the basics of how to find the area of a triangle. Today we're going to go over some word problems, specifically ones you're going to find on the first worksheet and the textbook questions. So follow along today. You'll have no problem getting these done. Please make sure you watch the videos. I have so many people who message me and say, Mr. B, I don't get it. I can't figure this out. And my first question is, did you watch the video? And if the answer is no, go and watch the video, because I'm literally telling you how to do the exact questions that you have in there. So let's start with a couple of just basic ones. So here is a triangle. It is an acute isosceles, and it is I have a grid here for you to figure out the base and height of this particular triangle. So let's start and look at the base of the triangle. So we know that the base of the triangle is the bottom here, and each one of these little squares on the grid is 1 centimeter. So this triangle is taking up 4 centimeters of the grid. 4 centimeters is the base. Now the height is the distance from the base to the top of the triangle. Now, if this was a right triangle, we would just look at the side length. But because this is an isosceles, we have to go from the middle to the top. So let's just look here. There's 1, 2, 3, 4, 5, 6, and 7 is the height. It goes 7 centimeters from the bottom to the top. And again, I know that some of you look and go, well, look, Mr. B, it actually doesn't fill in over here. Yes, I know that, but it also fills in little small parts over here. So it is 7 centimeters high with a base of 4 centimeters. Now, if we think back to our formula for how to find area of a triangle, we use the formula area equals base times the height divided by 2, because a triangle is half of a parallelogram. So the area would be, the base is 4, the height is 7, and we divide by 2. 4 times 7 is 28 divided by 2. And 28 divided by 2 is 14 meters squared. Okay, so this triangle has an area of 14 meters squared in total. That being said, let's go on and try a couple other examples. All right, guys, here is another example. This one is a right scalene triangle. It's got a right angle on the far right of the paper, and then it's scalene because all 3 sides are different lengths. Let's do what we did last time, and let's count the base and the height. So here's the base. It's right here at the bottom. It's also, actually, it'll also be the same on the top of this one. But 1, 2, 3, 4, 5 is the base. It's 5 centimeters, or 5 squares fill up the base. And for the height, because it's a right triangle, the height is right here. So 1, 2, 3 centimeters is the height. So it's 5 by 3 triangle. Now on the worksheets I'm going to give you, this part's going to be shaded in, but I just didn't do that on the board. So the triangle will be a little more obvious when you see it on the paper. So for example, all of this will be shaded in. So you'll be able to really see where the triangle is. It just on this paper, on the whiteboard. Well, whatever, I'll do it for you now. There you go. Now, again, we apply our formula, the same one we used from before. Area equals base times height divided by 2, because a triangle is half of a parallelogram. The base we said is 5. The height we said is 3 divided by 2. 5 times 3 is 15. And 15 cut in half is 7.5 meters squared. Or sorry, centimeters squared. 7.5 centimeters squared. Again, guys, so when you're doing these ones, count up the base, count up the height. If it's a right triangle like we're working with here, the height is just the side length. And then we multiply and divide by 2. All right, we're going to try 2 more examples of questions that are going to be a little trickier here. All right, ladies and gentlemen, here is another word problem you're going to see on your worksheet. It's going to have a rectangle and then a colored triangle on the inside. Now on your worksheet it's white, but on mine it's going to be blue. And the question is going to be, what is the area of the blue triangle? Okay, so what is the area of the blue triangle? Let's work with what we know so far. So let's apply our formula. Area equals base times height divided by 2. Okay, let's look here at our triangle. So here it is. We know that the base is actually going to be here, and the height is going to be the distance from here to here. So what do we know? Well, we're being told that the side here is 20 millimeters. So we're being told that this whole side is 20 millimeters. Well, that's also the height, because here we start here at the base, we go all the way here. That would be the height. So we know that 20 millimeters is the height. Now the question is, what's the base? Well, this is the base here. So it's the distance of the side of this rectangle. But over here, I'm only told that halfway is 5. So I don't need halfway, I need the whole way. But if halfway is 5, the other half is also going to be 5. Which means this whole side is 10 millimeters. Okay, so now we just continue with our formula. 10 times 20 is 200, and 200 cut in half is 100 millimeters squared. So this triangle is 100 millimeters squared. Okay, just to see how that works again, because the triangle is flipped on its side, the height is going to be the distance from the base to the top, and we're being told that this rectangle here is 20 millimeters from the base to the top. So that means the height is 20 millimeters. The base, however, we're only told is 5 millimeters is half, so we need to double it to get the whole base. So the whole base, because we were only being told that halfway was 5. So we need to double it to get 10. So 10 becomes the base, and 10 times 20 is 200. 200 cut in half is, what did I just say? 100 millimeters squared. So that's one example you're going to see in there. Again, I believe it's number 7 on your worksheet. So again, try that one out. It's just a simple matter of adding up the halfway point of the base to get 10. And otherwise, you just find your area like normal. We're going to try one more, guys, and we'll see how you do. Give me 1 second. I'll put it back up for you here. All right, guys, this is our last example here. There's a question identical to this in your worksheet. So follow along and you'll have no problem getting the answer. My drawing is off. I tried to get this even. It's really hard to do it on a whiteboard, so I apologize, but hopefully you get the point. The question is, there's 2 triangles here. There's one here that has a right angle, and it's a right scalene. And there's another one here that does not have a right angle. And the question is, do both of these triangles have the same angle? I'm going to just redraw this because I'm really not happy with the way it's looking right now. Let's see how straight I could draw my line here. Oh, not too bad. And I'm really not happy with the way this looks now that I've changed everything. So let's try that again. There you go. Okay. So the question was, do both of these triangles have the same area? Well, in order to figure that out, we need to determine the base and the height of each triangle. Because if they have the same base and the same height, then they'll have the same area. So let's look at triangle number 1. And we'll call this triangle here, this one on the left, triangle number 1. Well, the base here is the bottom. So look, it goes from here to here. So the whole base is 6.1. Okay, now the height, because it's a right triangle, because we've got a right angle here, the height is just the side length, which is 4. Okay, so now we have to check if triangle number 2 has the same measurements. If it does, then it will have the same area. If it doesn't, then the answer is no. So again, let's look at the base. Well, this second triangle here on the right also has the same base of 6.1 because it goes to the same side, so it's got the same base. Now, does it have the same height? Well, you could measure because we're not actually given a measurement, but even if you eyeball it, it looks like it's pretty darn close to being the same height. Even though it's not a right angle, it appears that it goes right to the top. So it does have the same height as 4 meters, which means these triangles have the same area because it's the exact same measurements. So again, when you do a question like this, you're not being asked to find the area. You're just being asked, do they have the same area? And you just really need to visualize this. You don't need to actually do the calculations because you don't really have the numbers to do all the calculations. But if you do measure, or you do just look with your own eyes, you'll see the height appears to be the same, which means it's both going to be 4 meters on both sides. And the base, they share the same base of 6.1, which means they have the same area. Guys, that's it for today. If you have any questions, feel free to message me on Google Classrooms and we can get together and do some math together. Or otherwise, if you feel comfortable, go ahead and start working on the second of 3 worksheets. There's one more that will be coming out tomorrow, and that one, or sorry, on Monday, I should say. And that one will have another video attached to it because there's a couple harder word problems. And then next week, I believe on Tuesday, we're starting with area of a trapezoid, which we will do our practice on Tuesday, our worksheet on Wednesday, and then our final one Thursday, and then Friday there's no school. So we're getting close to being done with our math unit. So either way, we'll talk to you soon. Bye, guys.